Hi, everyone. I'm Guy Helmers with Genome Studios, president, if you saw the little display. I'm here to share with you um, about a project that we're working on. So, uh, Genome Studios is in the very early stages of building a gameplay framework we're calling GS Play. And this is a framework that's meant to be oriented around uh, very intuitive systems and tools that allow you to very rapidly prototype, but also extend in vast ways. If you had a peek, we're trying to capture almost all of the features that we believe are quite necessary for almost all games, mostly character-centric and real-time games. There's some real juicy ones in there. So I just wanted to get right into it a little bit. So here we have our project, and every single GS Play project starts with the game manager. So the game manager is our anchor to all the rest of the GS Play systems, and it carries all the core kind of systemic, the true full game systemics features. So startup, setting up managers, and kicking the game into action. So the thing about this is that you put it in every single level that you're developing, and it allows you to enable debug mode, which then when you start the play mode, it enters you into the level you're working on. It can configure all the data and the setup the way that you want it, so that you can just hop in, test what you've been developing, and hop out rapidly, but also trigger it into a normal mode and allow it to then take you out of your level to the title screen and do a regular startup as though the game is being played by a user. So it allows you to really rapidly iterate. So speaking of managers, all the managers are contained within each feature set. They're all broken down into their own gems, but they extend the manager and the manager system. So you can get everything, save managers. We've made a bunch, but you can of course make your own unit manager, and camera manager. Uh, oh, cam manager. There we go. Um, we have UI managers, every manager you could want. But what I like about this, I'm a very haptic person, is that even though these are meant to be singletons, they exist. You can click around with them. You can add components. You can configure the components in the settings. You can add children. And all of these get started up in a orderly sequence through the game manager. So as you'll see here, we have save manager and a record keeper. Our unit manager has our player controller, and the entire unit system allows player controllers or NPC controllers to control any unit that you develop with the unit subfeatures. And then we've got the cam manager, which is our phantom camera system. Um, so what this does is it uses one singular camera throughout the entire gameplay experience, and then uses phantom cameras, which are just virtual cameras that define custom details about how they track and look and process and all these things. And so then by a priority system, the cameras then take over, and our main camera blends and replicates the details of those phantom cameras. So just a quick poke into it. Just to continue,
Yeah.
we are using a blend profile. So this is just a data asset, a generic asset that you can configure to set up any from cam to cam with blend types that have all sorts of easing and timings to very dynamically and cinematically shift between your entire arrangement of cameras. Um, and then, uh, lastly, we have our interaction system, which has a bunch of subsystems, but the one in particular I wanted to share is the world trigger system. So this is a two sides of the same coin little pattern, which is we have what we're calling trigger actions. So they act as the nerve endings that receive changes and action in the world, and then the world triggers, which then get triggered and affect the world and change things and manipulate things. So very quickly peeking into this, we have this button here. And as you'll see, we have a player interact trigger action, which means when you interact with it, it will respond. And what it's doing is it's triggering both a print log and a set record. And we saw the record keeper earlier. So what it is setting a little save state. And then over here on the gate, we have a record trigger action. So when a record changes, the nerve ending gets struck. If it's gate open record value 1, it's going to trigger the gate opening. So I wanted to focus on this in particular because what these are two separate trigger configuration little systems set up, but they seamlessly blend together and function between each other. So this allows you to really understand that you can make any sorts of changes and stuff in the world, and these systems can just pick them up based off of whatever's going on, quest progress, etc. And all these big yellow blocks are camera transition points. So let's get into it and see how it actually works together. Um, are you able to see this full screen?
I see, I do see a screen with the little character with the checkerboard floor.
Yes, okay, good. So this is our game. It started up. All of our tangent, oh my Lord, Git is asking me to update it right in the middle. Here we go. Sorry. Um, we have our game. It started up correctly. We spawned our character and possessed them. So now the player controller controls this unit. We've got our grounder and our movers moving them around. So just to quickly jump into the movers, we have free move, but when we extend to this extent of this ramp, we're going to switch to a slide move. And you can change any movers. You can have any number of movers, and they can do any effects that you want, and you can jump between them, grounders as well. We also notice here that we've got a bird's eye camera that's following our guardian here. And this is just an in-environment camera, while those other ones I was showing you were ones that follow you throughout the game. Um, and so then let's go on. Now we've changed to a static camera, a nice little Resident Evil look, really cinematic. And you can see the arrows here indicate that we have interaction pointing at our particular target. So when I click interact, the button gets interacted, changes the save gets read, and the gate opens. So then as we go, we see a nice blend to this more static camera. This one is actually the one that follows the Guardian throughout the levels. And this one's facing a particular orientation. But you can also, of course, get into more dynamic cameras that follow behind and track and orbit your character. Um, and these are meant to be in, you could have hundreds of these, even hundreds around your character. So this allows you to have camera blends and positions and angles and orientations and behavior across the board, attacks, damage, getting killed, getting attacked, doing spells, cinematic events, giant titan appearing in the horizon. It can be anything. And you can just trigger blending between them all. So I just threw these together, a little pickup. So similar to all the rest of the triggers, this just takes a collision, and when it collides, it quote unquote picks up. It just vanishes for us. But you can, of course, make world triggers that spawn particles, play a sound, make a number float out of the box, anything you could possibly want, change your inventory, all these things. So if you just walk into it, they get picked up. And then we just come here and we hit another cinematic blend to a nice, beautiful angle. And so really, I'm hoping that what this can show is that these tools are very intuitive and easily to deploy into a gameplay content situation. But I hope that the tools and the behavior behind them are sensible enough that both developers and engineers can satisfy custom needs, but that your designers can also intuitively deploy them, but also request features to be added. And just looking at this camera angle, I'm sure you can assume that just by changing the camera orientations and stuff, you can make all sorts of genres of action games, active player games. So yeah, we're trying to make a project right now to fulfill, satisfying all the feature needs, um, and try to get towards an alpha version of this tool set come next year. And that's
So,
everything I've got.
quick question.
Yeah.
Is your goal to open source this?
No, this is going to be a commercial product.
Okay. Because this makes O3DE extremely game jam viable.
Yes. This is very much oriented around larger scale studios using it for prototyping and proofing,
Yeah.
and indie scale doing an entire game production all the way through. Of course, we could be bought out and add it all to O3DE. But it's going to be quite a lot of work to make all these tools. So we do hope to get compensated. And of course, it allows us to continue to develop and update the entire framework continually as we build games.
Yeah. Let's have a discussion early next year.
Sounds good. Thank you very much.
Awesome. Thank you, Guyan. Are there any other questions for Guyan? Hi, Andre. Thank you for joining. All right. Well, Guyan is on Discord and has been open to questions and definitely helps out on a large part in our community. So if you do have any questions post meeting, feel sure to reach out to Guyan there. Colin, you asked a question? Or maybe Guyan, you can address that question in the oh, go ahead, Colin.
I was wondering where he was planning on selling his product.
Yeah, I mean, we're trying to find any real platforms that can work. We don't have anything concrete yet. We're more worried about making the actual stuff. But yeah, I mean, like, I know your market, potentially things like Gumroad. But yeah, like, we're not exactly sure where and how we're going to deploy it.
Thank you.
Thank you. Okay. Well, with that, then we are going to move to our next speaker of the morning or afternoon, depending on where you are. Reese Hagen is going to discuss Wayland support. Reese, thank you in advance. And if you want to start your session with a brief overview, an intro of yourself to the community, that would be great.
Yeah, I can. Is my mic working? Just making sure.
Yes.
It sure
Okay, good.
is.
I've never used Zoom before, so expect a little bit of it being a little scuffed. Anyway, I'm Reese Hagen. I've been working on the Wayland support for O3DE since about late 2024. I don't have any slides, but I'll just go over some brief points about some of the challenges and what are the benefits. Why are we looking into this real quick? So pretty much Wayland is the next generation of like a display server for the Linux desktop. Most major distributions are looking at dropping X11 support. You can run older X11 apps with a compatibility layer, but you won't be able to use X11 as your main display server anymore. But with that, you get modern features like HDR, multi-monitor refresh rates, and better high DPI support, which is very useful today with 4K monitors. And I'll show a little bit of some of it working real quick. Let me see how this works. I think this is fine. Yeah, sure. Anyway, here's the editor running in Wayland, and I'll just show you some problems. Currently, this is still Qt5, and I'll show you, just for like a brief, I don't expect you to understand this, but it's currently working. It's rendering Vulkan content to the editor. Wayland supporting Qt5 is a little bit, it's not fully baked. Currently, we're looking at just migrating to Qt6. Gualume has been working on that, and so we're just going to focus on work on that. But editor support is very not good right now. And I'll show a little bit of the actual game launcher, which is working a lot better currently. Oh, yep, there we go. So here's the game launcher. I don't really have much in this scene, mainly because it requires a song to be playing. But yeah, keyboard, mouse, input, all that works. Let me see.
So the goal of this is to allow O3DE to migrate to the newer display technology.
Yes.
Wait, okay, for Linux.
Yeah, because currently there's been a lot of people in the Discord having problems with the editor on Linux, mainly because they're starting to run 4K displays. X11 just doesn't handle high DPI too well. I will go over some of the challenges currently with it as a brief overview, because so far this is pretty much it. Multi DPI does, like high DPI does work. I don't really want to mess with settings because it might mess up Zoom, but multi-seat input should work with this. In theory, the code is there. If your compositor exposes a second seat where you have a second keyboard and mouse but as another user, they should pop up in the input as their own user. I don't remember how to get to it. Anyway, current problems with Wayland right now is that there is no standard desktop compositor requirements. So Wayland's core protocol is intentionally like minimal. So to make a desktop compositor, you pretty much are incorporating all these different little protocols to make it. And so it's been the challenge to depend on, well, what's required, what's optional. If it's optional, what is the fallback? Currently, XG decoration is the current problem. Decorations being the little like things that you have, like the title bar, the close, the maximize, minimize. And yeah, currently GNOME doesn't support it, and so does the Steam Deck doesn't support it. So the plan is to just enforce full screen, because if you're on the game launcher, you're probably going to be running the game in full screen. And if your compositor doesn't support decorations, we might as well just put you in full screen and enforce it. But so far, that's all they really have to talk about. HDR does work. However, the engine's HDR implementation right now isn't too great, but it's there, it's functional. So if anyone knows how to actually implement HDR properly, all of it's there to get it going. Other than that, I don't really have much else to talk about with this.
Thank you, Reese. Are there any questions for Reese? Feel free to either drop it in the chat or come off mute. You're getting
Yeah.
a lot of positive feedback on how awesome and cool this is, Reese.
Yeah.
FYI.
Definitely awesome.
Yeah,
was
sorry
hoping
for
to-
my stuttering. I'm very new to public speaking. This is my first time, so I'm very
Oh, you
nervous.
can't tell. You did very well.
Yes.
Thank you. All right.
Yeah, thank you for doing this.
Yeah, no problem.
Absolutely. Guyan, you want to come off mute and ask your question?
Are you able to hear me?
Yes.
Okay.
Yes.
I was kind of curious. You've been mentioning like GNOME and things. Is this meant to be that through Wayland you're hoping for spillover of compatibility into other OSs, Linux OSs?
Yeah, it should, as long as the Wayland, like Wayland is just the protocol. So
Oh,
this is just to implement the protocol into the engine, and any compositor that is made and supports the protocols that O3DE needs, it should just run on that
Oh.
platform.
that's excellent. That's excellent.
So I think currently, just for more explanation on that, currently I know it works on KDE, GNOME, Hyperland, Sway, Neary are some of the ones I know it works on right now.
What are the next steps for Wayland support in the engine?
Well, if we're talking about right now, it's currently getting it working with the editor. Editor right now has a lot of problems like you saw at the beginning. Mainly Qt5 just doesn't have the support needed. There seems to be some bugs with it. We're kind of hoping that with the migration to Qt6, that the problems will be a lot of the weird quirks will be solved. Mainly, Qt5 also has some like user experience issues. Like if you go to the file menu, it will sometimes be in the center of the window, but the input is still where you would expect it to be. Weird things like that. So the major next step is editor support and getting that functional.
And who's working on that?
Gualume has been heading the ways of migrating the tools to Qt6. I plan when he's done with like getting the things working, I'll try to start working off of what he's done.
Yeah, I'll follow up with him to talk about like approximate timelines and stuff to get that officially on the roadmap.
Sounds good.
Once
But yeah, awesome work.
Once that's done, what should we expect? Is it going to be faster? Is it no more going to be using the translation, or what's going on?
Yeah, we won't be using the translation anymore. I've seen issues on the O3DE repo where sometimes in GNOME with X Wayland you get some weird like lag when moving things around. So that should be gone with it just directly talking to the compositor. Wayland also can improve battery life because it's generally like better optimized depending on the compositor's implementation, of course. But if it's done right, you can have lower battery life on Wayland, and I forget what else you get out of it, but there's quite a bit of benefits to just skipping this and just getting rid of that compatibility layer. Other than just HDR and multi and like better frame rate and high DPI support.
Yeah, less visual issues when using modern display technologies like 4K and then eventually 8K.
Yeah, another protocol I want to see about getting done. It's not implemented yet, but fractional scaling is another one.
Nice.
Any other questions?
All right. Well, with that, everyone, Reese is also on Discord. So if you have any questions post meeting, feel free to connect with Reese there. Also, you can feel free to throw some questions in the chat if you have one during this call. With that, then we are going to move into our next speaker, Steve Pham, the creator of O3DE. And Steve will be going over memory usage and debugging in Linux. Take it away, Steve.
Hi, everyone. I'm Steve Pham. I've been on the O3DE development since we made it public open source from Amazon. Things that I've mostly been working on are all low like underlying systems stuff. So nothing that you would ever see on the back end. For example, I help push out the initial Linux implementation for O3DE. Worked on the sorry, the physics gem splitting the physics gem. I did the ARM64 support for Linux, and most recently, let me share my screen. Most recently, I've been working on getting the AZ framework libraries, which are a bunch of the core libraries that are not gems underneath code framework, converting them to a shared library. And the ones, there are a lot of libraries underneath this folder, AZ Core, AZ Framework. Each of them have their own purpose, but I focus on the main three, which is AZ Core, AZ Framework, and the AZ Tools Framework. That's currently in development, and it's also going to be released in the upcoming release in 2510. So some of the quickly, some of the benefits that came out of this was, well, the big main benefit was reduced binary size. As you can see, the installer for the general binary, because since the installer doesn't have any debug symbols, we save about 600 megabytes for Windows overall, and for Linux, we're saving about 3.5 gigabytes from the installer. But the big savings was in the debug symbols, and I'll explain why in a second. As you can see, Windows, we saw a reduction of almost 10 gigabytes, and Linux is actually 26, almost 26 gigabytes. So Linux is taking up a lot of memory in that space. Another benefit is if anyone, because this all applies to if you build from source. If you make any changes to any of the core libraries, let's say you go in and fix a bug, well, what would happen is um, since they're all statically linked in, you would have to link it against every single module. So you're looking at almost a full relinking of every module that is effective AZ core. So having this in, unless you change the header file, you'll notice that you can iterate faster by fixing parts in any of the 3 libraries, and it's only going to relink against. Actually, it won't even relink unless you change the header file. So it'll just rebuild the shared library itself. And what I'm going to demonstrate, and this is where it ties into Linux debugging, because one of the main reasons I wanted to start this project was debugging Linux has always been a large pain, especially if you have a low machine with low memory. So as you can see, I'll show you in a second. When you're running a debugger through LDB, the memory footprint before with the stack libraries for me ran up to 75 gigabytes, which is a lot of RAM. And then with the shared libraries, it was reduced down to 15 gigabytes. And you can find more information. Sorry, get a drink. There's an RFC posted on the SIG core site that kind of gives you more detail about it. So with that, what I want to do is kind of demonstrate the differences. So I created two sample projects. One using the static framework, which is the current release version, and for debugging, I use Visual Studio Code, and the particular extension is called Code LLDB. It actually works pretty well for me. You should be able to find it in the marketplace. One other thing is, if you don't know with Visual Studio Code, especially the way we the project and the engine are in separate folders, you would use a code workspace. And you can see this in Visual Studio Code documentation, how to set up a code workspace. You can set up any path as you want. In this case, the main project path is here, and then I set up where the engine, the associated engine for this project is built. In the future, you can also add paths to, like if you're working on a private gem or something like that, you can add that here, and it'll show up in the Visual Studio Code. So to demonstrate the difference, so what I did is I created a launch configuration, and this is in the plugins, that extensions documentation, how to do that. Very simple. It's just basically you have well, what type it is it LLDB, the name of the request type, the name. You can change this. I can change this to like launch editor, so you can create multiple ones. And what I would do is, let me start debugging. And what you'll notice, the reason I'm showing this is you're going to also see not only the memory space, but how long it takes to load each module. Because so while this is happening, the reason why we have such a large memory footprint is because when AZ Core, all the static libraries were all the libraries were static libraries. Their debug symbols were actually compiled into every single project that was linked. AZ Core has a lot of symbols. So does AZ Core and AZ Framework together has a lot of symbols. And what's happening was the PDB information or the debug information for those for everything in those libraries were compiled into the debug symbols for each and every single module. So we're having a ton of replication. As you can see, this is actually worse before. This is actually worse if you use GDB. That's why I generally use LLDB. I haven't looked into the reason why. And while that's happening, I can actually show you. As it's loading up, you can see right here where the memory usage for Coda LDB, the second one, is we're already up to 65 gigabytes of RAM. So if you don't have that much physical RAM, you're gonna start hitting the swap space, and sometimes you'll just run out of memory, and that made debugging very difficult, sometimes impossible. In the past, what I had to do was I would have to figure out which component I want to debug, and I actually either move out the debug files out of the directory so it won't even load them, or I'll just delete them. Oh, yeah, I don't know why it crashed, but that's not the point. So now to do show comparison with the shared framework version. Oh, I had set a breakpoint just for demonstration purposes here. Now, as you notice, it loads a lot quicker. And then you see the memory tops out around 15 gigabytes before we start up. And this is really important for just iteration for debugging on Linux. I felt because, especially if people are helping out, contributing to work, fixing some of the core libraries, so you won't. It will make it much easier to iterate through. So, wrong screen. So there it is. Any questions?
Wow.
That was a big difference.
Yeah, basically WoW sums it up. Yeah, I'm pretty sure Jan's going to be extremely excited to use this. So
Yeah, hopefully more people will help contribute to Linux on the Linux side, because it's on the Windows side. I mean, the benefits still hold. Obviously Windows isn't as drastic as Linux when it came to debugging, but minimally, the most important thing I think is having those libraries as DLLs, because now instead of having them linking statically, one change won't affect all the modules, right? You're just going to reload the same DLL. another potential advantage in the future is the ability to we can in the future we can have it's easier to make debug symbol packages. Like, if you want to download the debug symbols, if you want to debug into the engine from an installed engine, and having them smaller makes it more much more viable solution.
Yeah, when it comes to iteration, every second counts.
Yeah. That's it for me.
Yeah, I was just gonna say, this looks even just beyond the editor engine is like in production when you have to make hot fixes and quick fixes. This is enormous for production,
Yep.
like huge, huge, huge.
It also
Oh, yeah.
means you. Go ahead.
Yeah, that's true. Imagining with in the future, if we do patches, right? If we ever support like when downloading some like small patches, let's say a fix to one of the like DLLs, you in the past you'd have to update every single DLL, every single and all the exes. If there's any fix in easy core, now you just update unless the header changed. Obviously, you can just update the DLL, which is a big difference too.
Perfect. Are there any other questions for Steve or comments?